Alright, on this video we're going to talk about solving multi-step equations. There is a PDF of this available, so if you'd like to print that out and use that as your notes and then add some of your own work to it, that'd be fine. A couple things we need to know about multi-step equations. First is what are like terms, because we're going to be using them a lot. They are terms with the same variable or variable expressions, and they have the same exponent on those variables. The distributive property, we've been practicing a lot of that. That's simply multiplication across addition or subtraction. This is one of the techniques we're going to be using here to simplify. And then, of course, we always want to use reciprocals whenever possible. And reciprocals are two numbers whose product is equal to positive 1. So I'll give you an example here, 3/4, and the reciprocal of that would be 4/3. So in fraction form, it would just be flipped over. So that when you times these together, you end up with a positive 1. Here are the steps. You can go ahead and print that out or copy them down as is. We call it multi-steps, but it essentially comes down to just 3 steps. This one right here in the middle, we're not going to use today because we don't have, or at least not in this lesson, because we don't have variables on both sides of the equal sign. So we're really going to focus on 1 and then 3. But step 1 actually has multiple parts. You'll see it says simplify both sides of the equation. Well, that could mean a lot of things. For example, it could be combining the like terms that are actually on each side of the equation. We could distribute to eliminate parentheses, and then we may have to go back and combine like terms after we distribute. We could clear fractions. You don't have to clear fractions. This is an option. But sometimes if you don't like to work with lots of different fractions and the problems, you can go ahead and just clear the fractions. But this is an important key here, and I think we do have a couple examples here what we need to watch out for. It says that items inside the parentheses cannot be cleared or combined with items that are outside of parentheses until you've eliminated those parentheses. And of course, we might have to distribute to eliminate those parentheses. Best thing to do here is just jump right in. Multi-step equation, simplify both sides. This is already simplified, however, I do have like terms here. 8x's minus 3x's leaves us with 5x's. Bring down the rest of the problem that was unchanged, and now proceed with solving, what was it, isolating the variable by applying PEMDAS in reverse. Okay, so I have a times, I have a minus, so I'm going to undo the minus first by adding 10 to both sides. That leaves me with 5x plus 0, which is 5x, and then 20 plus 10 is 30. And now all I got to do is divide by 5 on both sides. 5 divided by 5 is 1. 1 times x leaves you with x, and 30 divided by 5 leaves you with 6. Now you are supposed to take this number here and go back and put it in place of x here and here to double check to make sure that it works. I will do that on this first one, but I'm not going to do it on the rest to save time on the video, but you should try it out just so that it works. So if I put a 6 in place of x, in both of these cases here, okay? Then we have 6 times 8, which is 48, and 6 times 3, which is 18, minus 10 is equal to 20. I have 48 minus 18, which is 30, minus 10 equals 20, and 30 minus 10 is 20 equals 20. Since that checks out, we know that the answer is x equals to 6. X equals 6. Next example, on this one to simplify, I cannot take this x, this 1x, and combine it with the 7x and call it 8x because it's inside the parentheses. In order to be able to combine them, I must first distribute my 2 to both the x and the 6. Now remember, distribution, or the distributive property, is nothing more than multiplication. So I bring down my 7x because I haven't done anything with it, and I have a positive 2 times x is a positive 2x. Keeping in mind there's a 1 out in front. And a positive 2 times a positive 6 leaves us with a positive 12, and the whole thing is equal to 39. Now I'm going to go, I'm still on step 1, so now I'm going to go ahead and combine some like terms since I've distributed. So now I have a 7x plus 2x, which gives me 9x's. Bring down the rest of the problem. And now that I've simplified as much as I can, I go over step 2, I skip step 2, I go to step 3, and then I do reverse PEMDAS to solve for x. So I'm going to minus 12 I still have a 9x on this side, because this is 0. And then 39 minus 12 is going to leave us with 27. Divide both sides by 9, and x ends up equaling 3. Okay. Right now we're working with all integer values as an output, but that doesn't mean I could end up with a fraction at the end. I could. I could have fractions up here, and I'll show you how to clear those out later on. Here's another one we have to distribute, but you got to be careful here. You are distributing a negative, so bring down the 6x. So we're going to distribute a negative 2 times x is negative 2x. And then a negative 2 times what is essentially a negative 5. Negative times negative is a positive. 2 times 5 is positive 10 is equal to 46. Next step, combine my like terms. 6 minus 2 leaves us with 4x's plus 10 is equal to 46. Now I can minus 10, and after I do that, I can divide by 4. So minus 10 from both sides. And this is called the addition property of equality. I have a 4x left over, equals 36. And our last step here is going to be to divide by 4 on both sides, so that we now have x is equal to 9. Okay, if you think you know how to do this now, go ahead and pause the video and give this one a shot. There's no distributing this one, so it should be relatively easy. If you have a solution now, the first thing we do is combine like terms. So 9d minus 2d leaves you with 7d plus 4 is equal to 32. And we're going to subtract 4 from both sides, because remember we're doing reverse PEMDAS when we have all the variables on one side. So I have 7d is equal to 28, and then divide by 7 on both sides, and d will end up equaling 4. Keep in mind that even though I'm not going back and checking every answer, you should take this number for d, put a 4 here, put a 4 here, calculate this whole left-hand side and see that it actually does equal 12. Multi-step. Here's where we have a fraction, and I'm going to show you this a couple of different ways. The first way is using reciprocals. So rather than multiplying this 3/2 times both of these numbers, I'm going to just eliminate the fraction on this side altogether by multiplying by the reciprocal of that, which is 2/3. That will give me 1, but in order to keep this thing in balance, I have to go to the other side of the equation and multiply those numbers over there by the same reciprocal of 2/3. So this will become a 1, this will become a 1, and 1 times this whole expression is just 3x plus 5. Over here, this is over 1. I have a negative times a positive, which is going to be a negative. I can take my 24, divide it by 3 first, and then loop up and times it by 2. So 24 divided by 3 is 8. 8 times 2 is 16. If you would prefer to do multiplication of fractions the standard way, which is just multiply straight across, you'd get negative 48 over 3, which when you divide will still give you negative 16. Okay, now I still have to get rid of my 5 because all my variables are on one side. So minus 5, minus 5. This is a 0, 3x. Make sure if you don't know how to do this in your head that you use a calculator. A lot of students get this wrong. This is negative 16 minus 5, which is not 11. It is negative 21. Divide both sides by 3. And x will equal negative 7. Now I did say I was going to solve this a couple of different ways. The first way was using reciprocals, so we should end up with a negative 7 on any of the other ways that we solve this. The next one is called clearing the fraction. So clearing the fraction just involves getting rid of the denominator portion of the fraction. There's only one fraction here, so I only have to worry about that denominator. Well, the denominator is a division problem. So if I have a divide by 2, to undo that, all I got to do is times by 2. So I'm going to times by 2 on both sides. So this ends up being a 1. 1 times 3 is 3 times 3x plus 5. And that's going to be a negative 48. Notice that I did not take my 2 and multiply it inside here because this is one big term. And as soon as I take care of one of the factors of that term, I don't have to carry the multiplication through the other factors of that same term. Okay, now we go ahead and distribute. And we get 9x plus 15 is equal to negative 48. And now my x's are all on one side, and I've already simplified as much as possible. I can use reverse PEMDAS here. So minus 58, I'm sorry, minus 15. So we have 9x is equal to, and again, use a calculator here because a lot of people are going to get this wrong. This is negative 48 minus 15, which is going to give you a negative 63. Remember, I should end up with the same answer as I had before. So all I got to do now is divide by 9 on both sides. 9 over 9 is 1. 1 times x is x. Negative 63 over 9 leaves you with negative 7. If you look back on the previous slide, you can see it was also negative 7. And last one's going to be a word problem where we have to actually write our own multi-step equation and then solve it. You're planning a scavenger hunt for 21 campers. That's an important information. That's a total. You plan to have 5 teams. 1 camper for each team will be the recorder, while the rest of the people on the team will be searchers. So we know 1 person is the recorder and the rest of the people are searchers. How many searchers will be on each team? Now this question right here, how many searchers, is what we want to know. So when we're done, we got to make sure that's what we're answering. They're asking for how many searchers. Normally I'd say let S equal the number of searchers on the team. I'm not going to do that because I don't like the letter S. So I'm going to say let N equal the number of searchers on each team. Okay. Now, how do we come up with an equation here? Well, I have a total of 21 campers. I know that I have 5 teams. If I knew how many people were on each team, I could just multiply by 5. Okay, so all I got to do is take total campers and let it equal number of teams multiplied by, what is it, campers? Yeah, campers per team. All right, I know what the total is, 21. I know what the number of teams are, which is 5. What I don't know is how many campers there are per team. So the campers per team is actually consisting of 2 things: a recorder, and the rest of them are searchers. So the number of campers per team is actually going to be represented by that 1 recorder plus however many searchers per team. So it's not just 5 times n, it's 5 times 1 plus n, because the number of people on the team is number of searchers plus 1. Okay, go ahead and solve that. 21 is going to equal, distribute, 5 times 1 is 5, plus 5 times n is n. Go ahead and subtract 5 from both sides, so minus 5. And running out of space here. So 21 minus 5 leaves you with 16 is equal to 5n. Divide both sides by 5, and we get 16/5, which is about 3 and what is it? 3 and a 5th. So about 3 people per team. So number of searchers. What's the question asking? Searchers, which is n. So n will be about 3 people per team. If you have only 21 campers, it's not going to work out exactly. So we can't say 3 and a 5th people, because there's no such thing as a fifth of the person. It's either a whole person or not. So we can't say 4 people on a team because there's not actually enough people to do 4 on a team, or 4 searchers. So it'd be 3 searchers per team, plus the recorder, which will make actually 4 people on the team.